Alright, welcome to our next tutorial. And this tutorial is going to deal with something called if statements or selection statements. This is where we start getting to the cool stuff, and that's where we're going to give our program a choice. And our lives are filled with choices every day, so this is one of the key concepts that you'll need to develop in all the different levels of programming. So we're going to make a program which is going to work out our age and whether we classify as being a baby, a toddler, a child, a teenager, an adult, or a pensioner, depending on which age that we plug in. So in order to do this, we're going to be working with a integer data type, because that is the person's age that we're wanting to try and deal with. So I'm going to go through and call it age as integer, and we need to get the integer of the age from the person. So we're going to ask the question to the user about what age they are. Okay, so under here we'll ask, how old are you? And then, similar to what we've done in the past, we'll go through and assign that to that variable, and we'll read that in. Alright, so this is where we get to the good stuff. Alright, so what we're going to do is we're going to type in the word if, and what we would like to work out is whether the age is in one of our groupings. So the first age that we wanted to consider is the fact that we want to work out if they're considered perhaps a baby. So a baby is going to be anyone that is under 2 years of age. Notice that this symbol here, called the greater than or less than symbol, depending on which way it's pointing. Okay, it's obviously a key mass symbol. We use this a lot within programming. So when we do this, if the age that was plugged in previously is less than 2, if I was to put in the symbol equal to, okay, that would say if the age is less than or equal to 2. That's obviously not quite the same as what we had before, so you have to be careful. If they type in the age of, say, 1, if 1 is greater than 2, which it's not, okay, so that will get skipped in terms of the code. It is trying to go through and work out what is the first statement which evaluates as true. So for instance, if I type in the fact that I'm 1 year of age, this line of code is not right, so it will evaluate as false. So what should we do if the person's age is going to be in this correct boundary? So what we're going to do here is we're going to actually type in console.writeLine, and we'll say that the person is a baby. And you could decide to give it a console.readLine now, but I'm going to do it slightly different, a little bit further down the track. Okay, so at the moment I'll do a read line, but I'm going to move this a little bit further on down the track. In fact, I'll do this now. I'm going to pull this out of my end if statement. Important thing to note when you have an if statement is that every if statement where it's got a decision which needs to be evaluated, you should finish that with the word then. That means that if that condition's been met, then do the stuff that's on the next line. The next line is what's going to occur. Every if statement you have needs to be finished with an end if statement, so it knows where to finish doing the checking. So in this case, I finished off doing the checking, and then as soon as I finish doing the checking, I'm going to give a pause to the program so that people can read what's happening in terms of the write line. So for instance, if I was to run this now, check this out, if I was to type in 1, it's going to say that I'm a baby. If I was to rerun the program and type in the number 2, is 2 less than the number 2? No, it's not. 2 is actually the same as 2. Okay, so if we had less than or equal to 2, that would evaluate as being correct. But at the moment, 2 is not less than 2. So when I push enter, it actually does nothing. Okay, so if we want to try and deal with babies that are 2 years of age, we'd need to change it to an equal symbol. Okay, but a child that's 2 is actually going to be considered a toddler, not a baby. So what if we've got more than one decision to try and work with here, like this is the case? Well, that's where we need to use an else if. An else if is basically giving us more choices to try and choose from. Okay, so in this case we're going to do the next bit of logic. So the next bit of logic that we've got there is anybody that is under 3 years of age is going to be considered a toddler. Next line of code after that, will be another else if, and we'll say that if the age is going to be considered less than the next boundary, which is going to be 12. And then if you're less than 12, you're going to be considered a child. Now, with an if statement is looking for the very first decision that is considered true, or selection that's considered true. So for instance, you might think that if I type in the number 1 here, why isn't this getting triggered? That's because of a very important concept called sequence. Sequence means that the compiler or the program will start running from the top and working its way logically through, trying to evaluate and do the things one by line or line by line. So for instance, in this case, if I was to type in 1, this condition here would be met, which means that the right line will display baby, and then because that's been met, it's happy, and it will pop out the bottom of end if. It will jump down towards the bottom, and then it will do the read line. To show this in action, if we come over here and click on the red blob, click on run, I'm going to go through and type in 1, push enter, have the focus back in this console, push F10, and you'll notice that it's stepped onto the next line of code. Because age is less than 1, this whole line has evaluated as being true, and as a result it will trigger this line of code to occur. After it's finished that, you notice how it jumped all the way down to the bottom here. So it skipped all of these checks. As soon as it's found one that it likes, it doesn't do anything else. After the line end if, it will jump to the console.read line, and then obviously that is when we will see the result of that. Okay, so in terms of the next thing that we wanted to do is check on if child's going to be triggered. So for instance, if I type in the age of 5, 5 is not less than 2, 5 is not less than 3, 5 is less than 12, it will run this line of code here. Let's verify that. F10, F10, you'll notice that this line of code gets highlighted. This is the line that gets written to the console, and then when we see the read line, you'll see that it's got the corresponding child. We want to try and keep adding to our selections here by having a couple more choices for us to try and work with. Okay, so the next choice that we're wanting to do is anybody who is less than 20 is considered a teenager. After that, we've got anybody who is less than 65 is considered an adult. Anybody who is less than 120 years of age is considered a pensioner. Now, it looks relatively simple the way that I've done it, but we can have some big problems if we try and reverse these symbols the other way. So, in terms of getting a pensioner, you type in the age of 69 or 75 or whatever, this condition is not going to be met. 75 is not bigger than 120, so this will never get done. Where students sometimes get confused is when they start doing this kind of stuff. They start thinking about putting things like, if I am older than 65, then let's do this kind of line of code here. Okay, so we're going to say that we're a pensioner here, or we might decide to do things like, let's do if we're greater than, I don't know, 19 perhaps. Let's change that slightly. If we're older than 19, you might decide to think, oh look, well then we're going to be an adult. The problem with that is that if we're a pensioner and we type in 75, because of the fact that 75 is greater than 19, this will get evaluated as true, and as a result, this line of code will get triggered, which is not quite right. So this is to do with sequence. The order in which you write things can make a big difference to how the code is run. So in that situation, it wouldn't quite be right. You've got to think carefully about your logic and how the program will respond to that logic. Okay, so I'm just going to undo that and take it back to the way it's meant to be. If this was the achievement standard that we're doing, this program is good enough for achieved. It's basically able to deal with expected values. So for instance, if we type in the correct ages, it's able to deal with all of those ages. So for instance, if I was to say that I am 110 years of age, can my program deal with that? Okay, so in this case, it's not. It's got the breakpoint on, so I'm just going to remove the breakpoint just to speed things up a wee bit. Okay, so if I type in 110 years of age, it's going to say that I'm a pensioner. It's dropped down all the way to this bottom line. Run that, And if I was to go through and do some additional testing, okay, I'm 12 years of age, going to be considered a teenager. That's not quite right, is it? So that's where we need to start looking at the logic. So in this case, we want to consider people that are less than 13 as being a child. So I'll need to change that slightly. What I was just doing there is testing things called the boundaries, and that's the kind of limits of each of my toddler groups, child groups, teenager groups, adult groups. That way you can work out if there are genuine problems or not. So if I was to type in 12 now, that small change I made to my code has made the corrected changes. Another way around that, it would have been to change it to something like this. And sometimes it's okay to do that. Okay, so if I'm less than or equal to 12, because we're dealing with whole round counting numbers, it's still fine to use if it's less than 13. If I'm 12.999 years of age, that condition would still be okay. Okay, so often when we test, we want to test around the fringes to make sure that we're okay. So for instance, if we want to work out that we're 19 years of age, it should be showing us teenager. However, if we type in 20, it should be saying that we're an adult. So this is my program now able to deal with expected values. That's what is achieved, is working towards. In order to work for merit, your program needs to be able to deal with numbers that are on the boundary. So for instance, if we type in the age of 0, that should be acceptable as an age for a kid, because as soon as you're newly born, you can be 0 years of age. However, you can't be a negative number. That would be impossible. So we need to have another line of code which is going to work out whether we're outside of our acceptable ranges. Let's say that our acceptable ranges for ages is going to be between 0 and 120 years of age. So one of the things that we can do here, before we start doing all this other checking, is I'm going to go through and add another if statement across the top here. I'm going to say if the age is less than 0, that means that if the age is going to be, say, negative number, then that's not acceptable. So I'm going to do a console.writeLine, and I'll say that that's not allowed. I'll put that's impossible. Okay, so run that program there now. If I type in a negative number, it's going to say it's impossible. Again, for testing around the fringes, we'd probably want to be doing the likes of -1, and then testing it on 0 to make sure that that's allowed, but -1 is not. So that's taking care of the lower numbers. The next thing that we could decide to do is we could decide to do the other end of the spectrum. So if the age is greater than or equal to 120, again, I'm going to say that it's impossible. Okay, now that's okay. Another way of doing it that's a little bit more efficient than that is to do something called complex operators, and that's where we use these symbols here called or and or not. Okay, so using or, I'm going to say that if the age is less than 0 or the age is greater than 120, this is going to basically trigger this line of code to occur. So this is now going to be the word impossible. So if I run this now and I type in 121 years of age, it's going to say it's impossible. Okay, so this is the kind of stuff that makes me think that students working at, say, merit or even excellence type level. So this particular program is now able to deal with all the expected inputs and also boundary data. In order to get to excellence, what we need to be able to deal with is everything that is not expected being plugged in. So things that are not expected to be plugged in were things like letters. If we plug in a letter to our program, that's going to kill the program, because we've said that it's going to be only able to deal with integers. So let's go through and test that to make sure that's the case. So if I type in, say, a special character or a letter, my program's not going to like that at all. It's going to come through there and try and store the letter A into my variable of a data type of integer and come up with this error message here, which is obviously not good. So we need to be able to deal with that before the error occurs in order to get excellence. And VB and C# gives us a couple of easy ways of doing that, and we're going to use a statement called try. It's going to try and do all this stuff here if it can, but if it can't, it's going to go through and give us a nice little error message. You notice when I typed in the keyword try and then push enter, it filled in all this extra stuff here. I'm going to grab that and move this down towards the bottom. So what this try routine is trying to do now is it's going to try and convert what they've typed into the console into this variable age, which is an integer. If it can't do that, it will jump down to the second sequence, which is called catch, and this is going to catch any errors that we might be having. So what we're going to place in this here is going to be catch the error, and then to the console let's write a little message here which says please type in numbers only. And that's pretty much then going to finish the console catch, and then we'll end up displaying the message back to the user. So if we try and run this through now and try and plug in that same error that we had before, what we'll notice when we type in a letter, it's no longer causing a major error, and it's actually giving this catch routine a bit of a run through and showing a nice little graceful error message to the end user. By doing that, we're able to work towards excellence in our achievement standard, because we're able to deal with expected values, which is in our correct ranges. We're able to deal with the boundary data, which is lower than 0 and above 120, and things that are not expected, which in this case could be considered letters or special characters on our keyboard. Another thing that we want to try and do, as I've mentioned in the past, is to try and add lots of comments to describe what's going on. So one of the things that we can do in here is we can add some comments above our sub-main, which describes what our program is supposed to do. One of the ways that we can do that is by pushing the apostrophe key 3 times, and we'll add something called an XML summary comments. At the top here, it's good to get into the habit of adding these summary comments to every program that you make from now on. So for instance, to start off with, put the author of the program. So for instance, that'll be your name and the date that you created this program. Okay, so the date that I'm making this program now, 27th of March 2014, and then finally get into the habit of putting the purpose of the program. So it's going to be working out it's an age checker program. Other things that we might like to do is to add some additional comments to describe what is happening with some of these crucial parts of code. So we don't want to comment every single line. That will actually mean that we can't get excellence, because that is not being efficient. We want to try and use good variable names and good internal names so that our code is self-documenting or self-commenting, but wherever some big important parts are going on, we add some additional comments. So for instance, in this situation, we're going to add the fact that we are declaring some of our variables across the top. Now we could have lots of variables that we're wanting to declare. In this case, we've only got the one that we're trying to work with. And I like to try and put mine off to the right a wee bit. And I'm going to put here that the try statement is used to catch any errors. And the error is going to occur when we try and store a letter in the variable age, which is an integer. Okay, underneath that, what we're trying to do here is we're trying to work out what is our boundary data. So I'm going to put in here that I'm checks boundary data. Underneath here, we're going to check for the different bandings, check for age bandings, and that's obviously going to come all the way down towards the bottom here. And then I might want to decide to comment this part as well. Perform this catch statement if an error, if non-number has been entered. And then provide a pause. Okay, so that's pretty much what we're trying to work towards with all the problems that we do from now on, whereby we're going to put some comments to describe the person who made it, the date that it was made, the purpose of the program, declaring variables, and some of the important stuff that's happening throughout the running of our program. In terms of us wanting to test the program to show that it's working for Achieved, we've got a couple of ways that we can do that. You can use pen and paper and write down all the different things that you're going to test on, because one of the things the achievement standards ask for is showing that you've got a good testing program to work for the different levels. So to to go for achieved, we need to make sure that our program has been tested against things that are critical for our programs, such as that if we plug in the number 9, that would be expecting that child would be appearing. If we type in the number 1, baby's appearing. Another way of doing that is by actually using the console and taking a print screen of our page. So for instance, I could go through and take some print screens of the result of this. If I took a print screen, go into something like Microsoft Word, open up a new program. This is an example if I was to crop this information down. This is me showing that I've tested on age 16. I could do that for each of the different boundaries and age limits to make sure that my program's working as expected. One of the things that's quite useful is when we start working with loops, we can actually have all this information in one single console window, and we can just take one print screen of one console window and use that as our evidence for the assessment. So once we get up to doing more things with loops, we'll be able to do that nice and easily. But that's pretty much finishing off this lesson working with if statements and a number of other concepts that we've covered today, such as adding good comments, including summary comments, and working with boundary data, and then introducing the try-catch statement. The try-catch statement is going to be really, really handy for us to use, and you can see to work towards excellence, all we need to use is a simple 3 lines of code, try, catch, and end try, and placing our little catch-all statement, which if we have an error which is generated with variables being assigned the wrong data type, it will pop down and do the catch statement. Okay, so that'll finish off our tutorial for today.